So welcome everyone. Good afternoon or good morning, depending where you're located. Thanks for joining us today. We have a really great webinar in place. Today we're going to be going over the safe use of electrodes in the MRI environment. My name's Max. I work in the marketing department at RhythmLink, and I'll be moderating today. So without further ado, I'd like to introduce our two speakers today. So first we have Leah Hanson. Everybody knows Leah, I'm sure. Leah is an experienced clinical advisor with nearly 40 years of experience in neurology, neurophysiology, electrodes, and medical device sectors. She's worked in the neurodiagnostic field as an EEG technologist, a department manager at the Children's Hospital of Wisconsin, an applications installer, and product manager for a capital equipment company. She's a previous board member and faculty member of FASET, the Asset Foundation, CSET, WSET and SET, as well as ASNM and ACNS. She is a results-driven achiever with exemplary planning and organizational skills, along with deep knowledge of the IOM, sleep, EEG, CEEG, and critical care healthcare market. So welcome, Leah. Really happy to have you join us today.
Thank you, Max.
Secondly, I'd like to introduce Sara Batson. Sarah's been a prominent figure on our most recent webinars. Sara is a multi-credentialed neurodiagnostic technologist with over 20 years of experience in hospital and private company settings. Her expertise spans multiple modalities within the profession. She has held the Board of Trustees position with ASET, was an EEG oral board examiner for ABRET for several years. She has held positions on the boards of state and regional societies. Today, Sara is also employed by RhythmLink International as our clinical solutions manager, providing clinical insights that influence patient care, advance clinical education, and shape product development. Sara has an associate's degree in neurodiagnostic technology from Scott Community College, and she also has a bachelor's degree in healthcare management from Siena Heights University. So welcome, Sara. Thank you again for joining us today. We're going to ask that questions be put into the chat. And then at the end of this webinar, we're going to try and dedicate some space to answer some of those questions. So yeah, without further ado, thank you everyone for joining. And I will hand it over to Leah Hanson.
All right, thanks, Max. I'm going to go ahead and share the screen. Hi, everyone. Thank you so much for taking the time to join us today. I think Sara and I and the team are super excited to talk about the education of MR leads, and just some topics to kind of revolve around all of that related to clearance and safety and all kinds of good stuff. So with that, we're going to move in. I know we already talked a little bit about our disclosures. As you know, Max had mentioned, both Sara and I, on behalf of Sara and I, we've been in the field for a very long time. Next year will be 40 years that I've been in the market. Like, I mean, that's older than probably like 2/3 of you like that are on this call. But it has been great. Like, you know, I've gone through from analog EEG all the way through digital transition and now into these great innovations. So well, with it has come like a bunch of like wonderful stuff, but it does make me chuckle every time I even hear that number. So thank you so much, everyone, for joining. As mentioned, Sara is a full disclosure, she's a full-time employee of RhythmLink. I am an advisor for Graham Partners, and I focus on RhythmLink. So I'm involved as well. So just so that you are aware of those disclosures. Our goals today, and this is just sort of going to be a little bit of just the general, you know, goal overview, is that we want to just all get a better understanding of the MR environment. The MR environment is a continuum of education. It's an area that we all should get more and more and more familiar with. Hopefully, even if you've been through a bunch of these webinars with me or anybody else, you're going to hear something that's new, and I think that's always the goal. We're going to talk about, you know, some electrode types, clearance protocols, and then also just like hazards and risks to patients in those environments. And not just patients, it includes staff members as well. So we're going to talk about those hazards. We're going to talk about that skin and the relationship of skin to the electrode that we apply. And that's, of course, the reason why we're talking about this topic in general, because leads are applied to a patient. And then we're going to talk about some real life scenarios. And, those moments where things don't always perfectly go as planned. And so what does that mean for our electrodes that are applied, particularly when someone goes into an MR environment? So we're going to start with just, some good sort of fun MR topic. And that is, especially if you've been in a webinar with me, or anybody else for that matter, talking about MR, there's these safety parameters that are of concern when we go into an MR environment. So when we leave our diagnostic lab and we go down the hall or we go down to a different floor with a patient, when they cross that threshold into that MR, and if anybody's ever been a patient, had an MRI, you know firsthand what it's like. There are these certain stages that they have to take you through as a patient because of the safety risk. And there's three, and this is sort of generalizing, but there's three main areas of safety concern. We all know, and I think most of us know, that MRIs, it's a magnet. It's a great big magnet. The good news about being around for almost 40 years is that I got to be around when MRI systems actually emerged on the market. And I vividly remember I was the tech at Children's Hospital of Wisconsin. They took us down to the radiology department and they wanted to show us some examples of the magnet, the power of the magnet. And, they had something, I can't remember what it was. It was some little piece of metal that they put even by the door. And you could see it move. You could see I forget what the item was. I think it was a necklace or something. You could see it actually move from the magnet. So the strength of that magnet is something that obviously has concern if there's anything on or in the patient that could be attracted due to that magnetic energy. So obviously it's a really strong magnet. As you see in that kind of first line there, one thing that we all should at least sort of understand, even if we don't kind of deep dive into every little detail of it, is that when you're in that environment, your protons are usually in a crazy spastic kind of direction. But when you go into an MR environment, that magnetic field aligns those protons. And this MR machine delivers these pulses. And when it delivers the pulses and those protons snap back, that snapback energy is what translates into the MR image. And I mean, I am never going to say that I'm a radiology expert. There's radiologists that could explain that way better than I just did. But, in sort of a general, very sort of simple sense, that's how that magnet's working to produce that image. So you've got this magnet that's, aligning these protons, it's measuring this energy when the pulse comes in, when it's snapping back from the pulse. But also what's happening within that magnetic field is there's this straightening or this torque or movement that can happen. And so if anybody's ever gone online, if you haven't, I encourage you to do it because they're kind of shocking and interesting all at the same time, is things get lack of a better description, kind of sucked into the bore, the center of the MR system. That's the torque. It's not just magnet. You don't see things in these images just kind of flying a little bit to the side of the machine. But instead, you'll always see these images of things that sadly, in a tragic, sometimes frightening way, fly into the center of that. And I'm not talking about an open MRI system, but a traditional closed MRI system. That's the torque. So it kind of straightens things out and then shoots them straight into that magnet. And then on top of the magnet and the torque, you also have heating. You've got this RF heating. You've got radio frequency energy in there. And this energy is high and intense in this environment. And what it can do is this energy can be absorbed by anything in that environment. So what's in the room matters because it doesn't necessarily have to be you could send something in that's not magnetic and think, oh, this is safe. There's no metal in there. Well, it doesn't have to be just non-metallic to be a danger to the patient or to staff or whoever it might be. If it absorbs energy, it can actually burn tissue. And it'll burn the tissue for wherever that device is touching the patient. And in our case, of course, with EEG, it's where our EEG leads are connected and applied to the patient. So where we've got an applied EEG electrode is risk not only of the torque and the magnet, but more importantly, in a lot of ways, the heat. And we're going to talk about that in the next few slides. So those are those three components of MR environment and kind of danger that we always want to be aware of. And again, it's this interaction with all these devices that make taking any kind of medical device or device in general into that environment of a concern and dangerous. It can heat up, it can move, it can pull. And last but not least, it can distort your image. So also, the patient goes in to have an MRI. If you can't get the MR done, if you can't get the image done, then also you just put that patient and the staff potentially sometimes even at risk, or at least like that time of caring for that patient, and you can't even get an image. So there's a bunch of different things in there that we always want to be aware of. Now we're talking about passive devices. Passive devices are devices that don't have any like electronics in it. So it's not like you're taking in, your cell phone. We're talking about just taking in like the lead wires of our electrodes. So I'm going to talk specifically right now about disposable EEG electrodes. The reason I'm talking exclusively disposable is because disposable lead wires, EEG lead wires, are made, nearly 100% from an ABS plastic base product that's coated or plated in something, gold plated, silver chloride coated, but it's a plastic base. And then it likely has some kind of conductive joint that is non-metallic in there as well, that connects the cup electrode to the lead wire. And your lead wire has little to no metallic material in there as well. There's different kinds of lead wire, but what you'd be using if the patient was going into MRI would be one that has very little metal, if any metal, in that lead wire. So I'm not talking about, a device that's got any electronics in it. This is a passive device, EKG leads, EEG leads, all of these things are passive. And the reason that it's still dangerous is because these passive devices can absorb this energy from the RF energy. It can heat up. The problem is we have no way to know it's heating up when the patient's in the scanner. And also, it's one thing if the patient was always awake and could say, hey, I feel something. I feel, I feel a sensation. I feel something. A lot of our patients, aren't even, they're not even conscious. So you got patients going in there that certainly couldn't tell you. And we certainly would never want relying on our patients telling us that they felt their skin having a sensation from electrodes. So these lead wires become antennas. And we know antennas in EEG very well because we know antennas as it relates to 60 hertz artifact, artifact in our environment. If you're an IOM, clinician, technologist, you're in that environment, you know how to handle all that environmental noise. It's because our lead wires are antennas. So it's not a foreign concept for us to understand and know it. Just absorb the fact that the takeaway is that this relates not only to artifact, but more importantly to heat. So when we talk about these, passive materials, again, these passive lead wires, these passive EEG electrodes, what they do is they amplify that RF energy. They can heat up. It travels down the lead wire, just like you see in the picture on the right where that lead wire touches the skin. And remember, we've also abraded the skin. So we've even, because of the abrasion, which we're going to talk about in a minute as well, we have impacted the protective layer of skin. That risk to the skin being injured is even higher. I mean, it's probably pretty minimal, quite frankly, in MRI, whether you've abraded or not abraded. But the reality is when we put EEG leads on, to get a good EEG, you probably abraded that location, applied your electrode, and now I've just got a little bit of a recipe for a risk if I'm not really careful with the device I'm using. So again, this is information that you'll hear about. Some electrodes for research can be shielded. So if you ever hear someone talk about like that's a shielded EEG electrode, or a researcher comes to you and says, hey, do you guys have an EEG lab? Do you have any actively shielded electrodes? Those are very specifically designed leads. So they can have a different design. They can be a longer lead wire, but they're also designed for different applications than just diagnostic EEG. So you might hear that language a little bit. And the answer is, typically no, usually you don't have them. But if you are at a high academic center, don't be surprised if you get that question. And your researchers might have some. And if they ever do, go take a look at them and get yourself familiar with those as well. Because again, it's just another type of lead to be aware of. But that concentration of heat is really what we're most concerned about. So when we talk about the electrodes in general, so we got, let's imagine we've got a set of leads applied to a patient. That risk to that patient, how do we minimize it as much as possible? And, and this sounds really simplistic, but just ensure that you're using FDA cleared MR conditional devices. I think, if you look back 10 years ago, 15 years ago, 20 years ago, there was not one product on the market that had been cleared by the FDA related to our field in EEG that could be used on a patient while they're having an MRI. Not one. There might have been products being used, but they were not cleared by the FDA. So they were being used through the IRB process. And I think most of you probably know the IRB process. That's really a process a lot of academic centers use. If they want to use a product in a way that it's not approved for use, you can actually go through a review process. You can get it approved for your facility, but then it's only used in your facility for that specific purpose. Until 2013, there wasn't any EEG lead on the market that had been cleared by the FDA. So since that time, so for those of you that are new and you've always had products available, this is still very new in our environment to have these products available. So be aware when you're looking at an MR lead, which we'll have some pictures of some leads in a minute, but when you're looking at these electrodes, they're designed differently. You've got your electrode, what I kind of call the business end, that touches the patient. Then you've got a much shorter lead wire, shorter than diagnostic. So, if you're in your diagnostic lab and you're using a 1 meter, EEG electrode of whatever manufacturer on your patient, you are not going to see that specific lead wire ever go into MRI anytime soon. The lead wire is simply too long. So when you look at MRI leads, the leads are shorter, and they're shorter because of what we just talked about with that heat and specific, that RF energy and the capturing of that energy that could happen from that lead wire. It's measured by something called SAR, which is the specific absorption rate. So these products are cleared off of a ton of good data of knowing how much, really like how much can tissue take. When I've got leads applied to a patient, like in whatever scenario on the patient, how much heat can generate on that lead wire before I'm starting to impact and damage the tissue, burn the patient. So that's what all of these clearances are based off of. So what we do know is this: you got to know the product you're using. You have to avoid strain relief loops. In EEG, we were always taught, and I was one of the people that we used to do little workshop sessions, and I felt like I was a master of being able to show how to do terrific strain relief loops. You can't do that for MRI. You want your lead wires to be straight. You want them to leave the bore of the machine, the center of that machine, straight. You don't want them looped. You don't want them coiled. So just be aware you're handling those electrodes differently. And that's why when you touch an MR product, the lead wire is significantly shorter than our traditional diagnostic product. And it's because of what we just talked about. Even a couple of inches. You've got to know the difference when you're looking at product options in length. So you've got some different varieties in the market. As you look at all your choices, you've got to be able to ask those questions to know what that length is doing or not doing in the environment of MRI. You need to know the testing that your supplier did to show and prove safety. Every manufacturer that produces a product that gets cleared in any way by the FDA has to have significant data to prove what they're saying to be safe, and then ultimately it gets cleared by the FDA. But I use the word cleared. I'm not using the word MR compatible. I'm not using the word MR friendly. I'm using the words, as hopefully you're noticing, MR cleared. You are cleared for a certain set of conditions. the term MR compatible is still used all over the market. You know, physicians use it, techs use it, you know, sometimes radiology staff members still even use it. It's sort of an older term. It's been replaced by the terminology of MR cleared and MR conditional. Conditional means it was cleared under a certain set of conditions. Those conditions are published and have been documented by the supplier and the manufacturer of that device. And I'm just going to give you a very simple example. If you've got a 3T, so that T is the strength, you've got a 3T MRI system in your facility today. That's what your facility uses. Next week, they announce that, guess what? They bought a 9T. So they turn to you and they say, hey, the product that you're applying to that ICU patient for the MR cleared product, are those cleared for a 9T? You go back to your manufacturer or supplier and say, hey, what's the clearance parameter for strength? You know, if you don't know it, you say, what's the clearance parameter for strength on this? And the reality is, unless that manufacturer has cleared and been tested as an MR conditional 9T product, even if it's very safe on a 3T, even if you're sure it's going to be fine on the 9T, it cannot be used in a 9T setting if it hasn't been cleared under that condition. So what we're having to learn for new information as clinicians and partners to our patient and our radiology teams is a new kind of forefront, a new frontier that we haven't had to do really, you know, except in the last 10 years. But we have to get in. We have to get into this conversation. We have to understand what we're looking at. We have to understand the terminology, because you've got multiple choices in the market, and it's critical that you understand the differences of each, so that whatever product you end up bringing in to use on your patients, you and your teammates in radiology, you know, ICU nurses, all the folks bedside, everyone is on the same page for the safety and the specific criteria of how to use that product. And you are the champion of using your product. You know, just because you haven't in the past been pulled into an MR meeting, you should be requesting to be pulled into these MR meetings if you're the team that are putting leads on a patient. So if you're in a setting where you feel like you're not getting a voice at that table, start asking for a voice at that table. You may or may not get it sometimes, but keep asking, keep asking, keep asking. I have asked for the last 40 years. Don't always get everything I ever wanted, but I keep asking over and over so that I can have a voice at that table. And that's how you learn, and that's how you become part of the process. So understand that lead wire, understand the safety. That lead wire length is your number one focus that you want to pay attention to. Because again, as we talked about in those first few slides, I'm not going to, continue to say it because you're probably sick of me saying it, but it's going to absorb that heat. Even a couple inches can make a difference. You've got to know the safety and clearance parameters of the product that you're using. One example, and I used to have a video of this and I couldn't find the video, but in a microwave, one perfect example is in a microwave. If you have a short spoon, a metal spoon, and a long metal spoon, you can put them side by side in like the video is two different matching microwaves. And they put little thermometers in there to see how fast they heat up. The longer spoon skyrocketed in how quickly it absorbed that heat from the microwave versus the shorter spoon. It's the exact same scenario that we have in the MR environment with our lead wire length. So ask about the product, ask about the lead wire length, because it does directly affect it. And the one reason why we have to be good at heat and understanding heat, which I'll show in a couple of slides, is when we abrade the skin and we talk about skin breakdown, which that doesn't matter if you're doing that in an MRI environment, diagnostic outpatient EEG, sleep studies, whatever. If you are abrading the skin, putting an electrode on it, then securing that electrode down like we all have to do to get a good EEG, you now have created non-intact skin. Non-intact skin can look like a burn when the patient comes out of the MRI, if someone would remove an electrode, and not know what they're looking at, it can look similar. So say you have a patient that's been on for 4 days, and maybe they even have skin integrity risk. So whether it's pharmaceutical or other things, they've got a reason why we're worried about their skin health. And then they have to have an MRI done. So the beauty of it with MRI leads, I'm not having to take the leads off and reapply for the MRI. I leave the leads on, which is great. Patient goes to the MRI. Patient comes out of the MRI, and then a new staff member, a new nurse comes in because the patient's going to be discharged, and it's 2 o'clock in the morning, and they're just going to take the leads off. If they don't understand skin health, skin breakdown, what we have to do to get a good EEG, there could be confusion initially with just skin breakdown from abrasion versus MR risk and injury to tissue. So long story short, understanding that heat becomes important, because what likely would happen in that scenario, they would call a dermatology consult, and that would help them understand what caused, if there's an injury. Because let's face it, we've all had it. If you've been doing EEG and you've never had skin breakdown, I absolutely commend you. I can tell you that, especially younger in my career, I worked at Children's Hospital of Wisconsin. Many of those patients were high risk skin breakdown patients. I was very good technically, especially before I had my own children. I was very good technically. I was quick, I was fast, I did a great EEG. I also left abrasion marks on my patients. And it wasn't until I started to understand the skin better, and frankly, become a parent, that I started to research better, how can I do a great EEG, but have less skin abrasion? And this was, by the way, as mentioned, 30, 40 years ago. So we also didn't have the same kind of product that we have now to help with skin health as well. But long story short, I had great people like Lucy Sullivan and other mentors in my life that helped me with my technical skill set. So I know I diverted there a little bit, but like that skin health and this heat conversation and tissue injury, they actually dovetail sometimes. And so you, again, want to be the expert, as much of an expert as you can be on both sides of that equation. Now, when our folks go, to go get cleared by the FDA, they have to go through a lot. So, I mean, I can't tell you how much. It's like a ton. It's expensive, it's long, it takes a lot of work. So anybody, and again, you've got options in the market. Any of these folks that have come out with product have done a lot of work to get there. But it's still the fact that they're all a little bit different. And every manufacturer is tested in a little bit of a different way. So what that does is it goes through a process of safety. It goes through something that's called, worst case scenarios. Like, for instance, and we're going to talk about it in a minute. What if the patient has 3 electrodes that get yanked off on the way down to the MR suite? Does that matter? Like, we'll talk about that, towards the end. Those are the kinds of things that leans into worst case scenario kind of testing, because our patients do not perfectly behave themselves every single minute they're connected. We know that, and so we have to address it. We have to be ready for it. So when you look at these clearance parameters, you're going to look at it in a document called an IFU. And the IFU is instructions for use. And it's also got MR symbols on it. So this documentation, which we're going to show some examples in a second, but this documentation has symbols that tell you if something has been cleared by the FDA as MR safe, MR conditional, remember, not MR compatible anymore, not MR friendly, MR conditional off a base of conditions, or MR unsafe. So first pass, you always want to make sure that you understand those symbols. You can recognize those symbols. When you see it on packaging, you know what it means. That's something that's just in our life now. That should be something that becomes second nature at some point, hopefully in our field and just in our technology in general. But you want to dig a little deeper. Make sure that you understand MR safe. It means that it's been noted that it's not expected to move, to heat up, distort the image. It's completely safe. I'll give an example. most bandages, most medical tape are listed as MR safe. Sometimes whether it is a lotion or something like that, MR safe. Sometimes things aren't labeled at all. And so that if it's not labeled at all, then it's up to the responsibility of the radiology folks and the technical team to determine if they believe there's a risk. But if you do see it labeled as MR safe, you know it's gone through a process and you know that it's been deemed that there's nothing that should be concerning with that device. If it's MR conditional, as we talked about, this means it was cleared as MR conditional under certain conditions. And those conditions will be listed in your IFU. So instructions for use. It's either in your packaging or it's on the website or somewhere. But if you're not looking at your IFU, you want to be looking at your IFU because there's information in there that's going to lead to what we just talked about with heat, absorption, all the specifics of how to use it safely in the MR environment. And then MR unsafe. MR unsafe is something that we just know is going to heat up, it's going to move, it's going to pull, it's going to do something. I'm going to give you an example. In our field right now, it's a subdermal needle for OR. Even if I take a subdermal needle, which is stainless steel, so let's, I know there's different metals out there, but assume a stainless steel 13 millimeter IONM needle. If you decided that you want to use that in an MRI, even a very short lead wire, it will heat up too fast and it will burn the patient because that heat will absorb too quickly with the stainless steel, not to mention the magnetic piece of it, but the stainless steel and then the lead wire. So, there's a combination of things that, one would want to look at if they were going to, go down that path of trying to figure out how to use that kind of product in an MR environment, because there's just too much of the product that will either pull, move, or heat. Don't substitute or mix and match products unless you know it's safe. And that is something that is easily done, especially when products look similar. You might, when I was with RhythmLink, which I was with RhythmLink for over 20 years, when I was with RhythmLink, we get phone calls and then people would sort of, ask questions. Can I use, this device with this device and that device and this cardiology thing and, this, and the reality is unless it's been tested together, no one can say for sure unless it's been tested together. So not saying you're not going to have patients coming in with other things in and on their body that aren't in the neuro lane, but things that we can control. So products that are in the neurology realm, so your different versions in the market, be very cautious mixing and matching products unless you know the safety of the mixing and the matching. Because again, every product's been tested differently. Every product has a different IFU. And we're going to look at those in a minute to kind of show you a little bit those differences. So never substitute, never assume, especially as it just relates to appearance. You've got to know the information. That IFU that I mentioned, they're tucked away in all kinds of places. They can be in the box or the pack, the pouch, wherever you get your leads in. They can be online. They need to be readily available. So if you haven't seen your IFU documentation, which by the way, it looks like that wonderful thing that when you open a box of Visine for your eyes, you get that tiny little piece of paper that opens up to a foot wide and it's got font about 2.5 and it's in 5 different languages. That's the IFU. And it's there because it's required to have that documentation available. So for instance, and this is just, there's many examples. This is one example. So this part of this IFU talks about, prepping for that application process. It talks about what product to use as the conductive material. It talks about that it's been approved for use with certain conductive materials. Again, if you use that specific, in this case, if you use Weaver, that's great. If you don't, you need to ask the question to that manufacturer. Can you use a different conductive paste? If they haven't tested with it, they're going to come back and tell you they can't give you any information because they haven't tested with it. If you are using a product that's not mentioning it, you got to ask the question, because anything can cause that risk of heat. Anything can cause, it's unlikely a little bit in our field, and I'll say unlikely like with a little bit of asterisk around it, that torque and that piece, like conductive gels and things, likely are not going to be a risk. But as we've talked about now, you're probably getting sick of me saying it, it's all about that heat piece. Anything attached to that sort of arrangement and that assembly of what we're doing with the patient's electrode that'll increase heat is of concern. So look at that IFU. This IFU on the bottom also has the last line that's somewhat important, and that is it talks about the configurations of 2 to 48 electrodes. Now, we don't typically use 48 electrodes on any given EEG application. We don't usually use 2 electrodes. But I'll tell you, one of the things that I thought was always really interesting that I learned, and I like to repeat it every webinar, so if you've heard one of mine, you're going to hear it again. Think about all that RF energy running around the MR suite. It's more dangerous for the patient the lesser number of electrodes you have on the patient than if you have more electrodes on the patient. So I'm more concerned about when I've got 5 electrodes, 4 electrodes, 3 electrodes, 2 electrodes, versus having 24, 28, 30, or 48 electrodes on the patient. Because that energy can be absorbed by more electrodes and then ultimately be a little bit less of a concern than the lower number of electrodes I have. So in EEG, sometimes I think we think like more electrodes make it more complicated, maybe more dangerous. It's actually the opposite in MR. So always keep that in mind. The lower number is actually an increased risk factor. So real quickly, and I'm going to scooch through these last ones pretty quickly. These, again, are just 2 examples of 2 different manufacturers' IFUs. So as you look at these, you look at the details that are in there. What's included in there, ask questions about. What's not included in there, ask questions about. I mean, if there's language in there that gives you discretion, for instance, on using gels or paste of different types, you've got to ask the question if it's been tested with that manufacturer of the gel or the paste. The answer might be yes, the answer might be no. If the answer is no, then you and your team at your facility has to make that determination if you feel like there's a risk. Could be minor, but it's still a process you have to go through. Again, this is an example of the one that we saw a moment ago. This is another one, and this one is interesting because it gets very specific about placement. So for instance, we talked about this already, the 1020 paste, and even your collodion. Like if you're using paste or collodion, it's a question that you should be asking about testing. What was tested? You also want to make sure, by the way, if you've got electrodes that, and we're going to look at leads, this term array, an electrode array, it's a multi-lead connector that has a bunch of leads coming out of one connector. Can you have leads just dangling? Can you cut leads off if you know you're not going to need them for that patient? Those are questions you have to ask and you want to ask, because again, it's all about what's it doing to that environment. If my leads are dangling, how many leads can be dangling? Is it 1? Is it 10? Remember, if I only have 3 leads applied and I have 27 or 20 or 15 they're dangling, does that matter? So make sure you ask those questions. And on this one, again, which we talked about, this last one I'm just going to mention, it talks about even the application of the electrodes. It specifically says in the IFU, there's no concentration of electrodes, that they are evenly spaced over the entire scalp. So that means if you want to apply extra electrodes to that patient for a focus, you need to be aware that actually was not part of the actual testing process of this particular device. It also comments on the bottom that it uses a sponge to keep the connector off the scalp. We talked about where that heat comes from. That heat comes from the contact of the skin. That sponge is placed to keep the contact of the connector off the skin. So you need to understand, if you're using that device, what if that sponge becomes dislodged? What if that sponge isn't available? What if that sponge, gets lost somewhere in the mix? Can you do the MR safely or can you not? And that's questions that I can't answer here, but it's questions you have to ask and get that answer. So, all of this is good for efficiency. I'm going to kind of like fly through this a little bit. This is just, some good examples and pictures of various options that are out there in the market. The arrays are those little connectors you see in this picture. Many of you maybe have already seen those already. They're great for efficiency. You also have individual connectors as well, like you see kind of in the middle there on the upper sort of left side. Those are great and can be handy as well to mix and match. Again, if there's known documentation of mixing and matching. Sticky pads and things like that are also sometimes available in the market as well. And again, we're concerned about all of this because we're connecting to the skin. If our industry 100 years from now uses an electrode that's a ray of light and we're not actually touching the skin, guess what? This entire presentation gets changed because none of this matters. It's all because we're touching that human skin. And you have to remember, because and this was something, I'll just say it for just a quick second, for years and years, and I was one of those people, I kind of fought back a little bit that we were doing anything to the skin when we abraded the skin, when we quote unquote prepped it for an EEG. The second you prep it, and you can look at the back of the labels, by the way, of any of your abrasion product, doesn't matter who it's from, New Prep or whether it's some other product, it's going to call it an abrasive agent. That abrasive agent, when you rub it on the skin, makes it non-intact. So it makes the product a semi-critical item. FASET's got great materials on this. I'm not going to go deep into it, but the reality is, just by applying the electrode, we are introducing some risk. So you add a little heat, a little danger environment to it, and it makes it even worse. And this is just an example on the left where it kind of shows a pressure. That was pressure injury from the lead wire. And as you can see, and this is what we talked about, that this patient came right out of the MR and somebody didn't know anything about what was going on with our application technique, this could be confused with something else. So that's why understand your responsibility of application, and then also just of pressure and using flat leads and things like that. That's what this slide's about. I'm gonna let it you kind of read it at your leisure, but you want to have leads that are as flat as possible so you don't have pressure like on that non-intact skin. Less pressure will absolutely equal better skin health. And again, FASET's got some great references on that. So with that, I'm going to stop. Sorry for flying through the end there. I'm always like, oh, I can get it done in 20 minutes. And then I'm always so much longer. I'm so sorry. So I'm going to stop sharing. I'm going to let Sara take it from here.
Okay. So thank you very much for that tee up, Leah. That was amazing. I'm honored to be able to do this webinar with Leah. I met her as a student and she has been a mentor in the field for many years. So we're going to go ahead and go into patient scenarios now, thinking about what Leah just shared with us. So I hope everybody can relate to us here as we kind of go through some of these, especially when you think of you're at the end of a shift, you get that order, never fails, that order coming through at the last minute. They want an LTM or a continuous EEG, whatever your facility may call it. And either you yourself, the neurodiagnostic tech, or a colleague, or both of you maybe, go up to hook this patient up, and you're going to use some MR EEG leads. And this patient, runs for several hours with these leads on, and then there's an acute status change. And so the patient's team has determined that they need to go to MRI. So the patient's then transported to the MRI, and there's multiple people involved in that process. Sometimes it's the transport team, and sometimes it's nursing. Sometimes they're doing it together. But what they don't ever have is usually the EEG tech helping with that transport. And if it's in the middle of the night, no one from EEG may be there, or they may not want to call them in. So now you've got these electrodes that were placed, but no one's had eyes on them that knows what a 1020 system is, and the patient's in MRI. So now hopefully you can relate to all of that. And we're going to kind of go in and I'm going to set the stage a little bit here. That either there's no on-call at this facility or there is an on-call, but you're using MR leads because either that's your policy or because the doctors have determined that you're short-staffed, as we all are throughout the field. I'm sure we all can relate to that. And they don't want to call a tech in the middle of the night to be hooking up and unhooking. And we really do care about the patient and skin safety. So the whole point of the MR leads for most facilities is, hopefully I'm correct in stating this, is because you have determined that that's the best possible case scenario for your patient to just be able to unhook and go to the MRI by the nursing staff. So again, no one from EEG has had eyes on this though. And we're going to go into the first scenario. I know some people have, like myself, have worked in peds only, some adults only, and then I've also worked in a neonate to geriatrics. So whether you have a peds patient or adult patient, this patient has had a convulsive seizure. And it's resulted in multiple leads being ripped off, or they're now off the scalp. And oh, we've got a poll that's coming up. I want everybody to be able to participate. So do you think that this is going to be a problem or a no problem or a possible problem? If these leads are ripped off and maybe they were pasted on, maybe they were glued on, if you can just go ahead and click there if you think it would be a possible problem or no problem. And let me know what you think. And so, yes, it is a possible problem. And it is a possible problem because, like Leah just said, we need to call and ask for the IFU if it's not stated on there, whether or not how many leads we got on, and if it's okay for them to go to the MRI. So we can't say it's not a problem at all unless your IFU states that. So we're going to go ahead and go to the next one. And the next scenario is, again, it could be either a peds or an adult patient. And they're in ICU and they need a drain placed at bedside to evacuate a bleed. This is an urgent situation. Neurosurgeon is coming up there and they're going to go ahead and they're going to remove some leads so they can put that drain in. So again, we need to consider if this is a problem, if this is going to be a possible problem or not a problem at all. Because does the neurosurgeon know what the 1020 system is and the international head measurement placement designated by ACNS? And if he removes something, is it okay, or does he need to put it back? And can he put it back if he's already put a drain in? And my poll disappeared, Max. I'm sorry. So the next scenario.
Sorry, Sarah, I was going to say, I think attendees can still see the poll.
Okay, I can't see the poll, so I'll let you go ahead. Is it okay for me to go to scenario 3?
Yep.
Okay. And I apologize, everyone. This is our first time doing the poll, but I really wanted to make it interactive for everyone. So scenario 3. Now, this one is a pediatric patient. And because a lot of times with our peds patients, they have to have head ultrasound. And so they're up, and maybe it's an ECMO baby, and they're in CVICU. I've had this happen before in the techs that I worked with, so I'm sure you're familiar with it if you've ever worked at a children's hospital. And the baby needs to have the head ultrasound. The tech goes up there for head ultrasound, and they remove a few leads so they can get to their windows and see. But then they need to go to MRI. And again, it's in the middle of the night and maybe there's a tech in-house, but maybe they're not available immediately, the EEG tech or the neurodiagnostic tech, to go down there and take a look. Because we're not all just sitting around waiting to be called to go take a look at leads, right? Especially when we're short-staffed. So this patient needs to go. They have leads off. Again, is this a possible problem or is this not a problem at all? We need to refer to our IFU, and if it's not stated in there, then we need to find out by calling our vendor and asking our vendor. I'm going to go ahead and go to scenario 4 because I know we only have about 7 minutes left and I want to be able to give you guys some time to ask some questions. So, and we've got a few more scenarios. So peds or adult patient, again, leads have been removed. They're an awake patient, they're up and mobile. So maybe it's because they've scratched, you know, or they've pulled at them. Maybe they've even kind of sat and picked and you weren't able to talk to them to tell them to stop picking because you're remote monitoring, or maybe you don't have an intercom system if you're doing the monitoring from in-house. So for whatever reason, they've picked, pulled, scratched, whatever, and they've got some leads off, or it's late at night and there's nobody there. So again, now they're going to MRI, and you need to know MRI and the medical staff needs to know, is this going to be a problem or not? And there you can see in this picture that we've got leads off dangling right there. So it's all about educating all of our medical staff. So scenario 5, we have peds or adult patient. When they're in ICUs, they're unable to get up and be mobile and move around themselves. The nursing staff is positioning them, and they're positioning them on a rotational basis. And sometimes our leads can become dislodged. They can get tangled up. They can get, you know, pulled off, whatever. And it's not on purpose. It's just because sometimes that they're doing other things and they just forget about the leads being on. They don't know how to handle them like we do. And then what you run into is now these leads are off and the patient has to go for imaging. And there's nobody available to put these leads back on, and the nurse isn't aware or sure where they go. Scenario 6, again, is a sterile procedure at bedside. They need an ICP placed. It's an urgent situation. So medical personnel is going to come to the bedside and they're going to remove leads and they're going to place this ICP drain. So we need to know, is this going to be a problem or a possible problem, not a problem at all, if they need to go to MRI now? Because no one's been able to look and see what the 1020 measurement, how off it is, how many leads are off. Is it, you know, a couple leads, all the leads, or are there only 1 or 2 leads still left on? Scenario 7 is peds or an adult patient receiving respiratory care. Same thing when they're in the ICU settings and they're on the ventilators. Respiratory, they try to be careful when they're sectioning, doing breathing treatments and all those things. But sometimes it just happens. And maybe there's 2 leads off on array number 2, but the other arrays are okay. So is that going to be a problem? A possible problem or not a problem at all? And I apologize again, I can't see the poll answers. So we got 2 more. Scenario 8, we've got a patient with less than a 35 centimeter head circumference. So this means we're going to do a double distance according to ACNS guidelines, the way we've all been taught over the years. I've been in the field 20 years. This was how the instructor taught me and my mentors. And 35 centimeters can be almost any age, because Zika virus, you know, you can have an older child that has a 35 centimeter because of microcephaly from Zika virus or something. So we just need to know, is it okay if only half the leads, you're talking 13 leads, are on the head instead of 26? And the last one, I'm sure none of you can relate to, And that is, you've got a new tech or a new student. Maybe that new tech is a traveler or just a new employee in your facility. Maybe the tech even was sent over from another facility to help you out because you were short staffed and they were able to spare somebody. So you go ahead and you've got this newer person that isn't quite familiar with your policy, your department, your workflows, maybe not even your EEG equipment or your electrodes. And they're in a rush because there's a stack coming through and they're just trying to help out. So is it going to be a problem depending on how they hook this up? So, could there be a possible problem? Is it important for us to educate and let everybody know what our policies are and how to do perform our job duties and the workflow? So I'm sorry, it's only a minute or two, but I want to go ahead and open it up. That is all I got. The takeaways here is just that we hope that, you have a better understanding of the IFUs and the MR environment and the unique and unplanned patient situations. And that electrodes, there's various different ones on the market for MR and that they can look similar, but there are significant differences that we all need to be aware of so that we can weigh those options. And we'll go ahead and take questions now. Thank you.
Sarah, I'm sorry I went so long.
That's right.
I can't help myself once I get going. My poor husband.
Is there anyone I think we had a couple questions from when you were talking, Leah. I know I seen Sean had a question. There was another tech with a question.
So there's a couple of questions in the group here for Leah and Sarah. So the first one I see is from Sean. Has there been and testing research on impedance variability and risk of tissue health with MRI/MRI leads? If a PT has been on for several days and you have a couple of electrodes at 12K and the rest at 3K ohms or less, are the higher impedance electrodes more likely to have a burn/tissue damage?
So I can answer that one, and that is not to my knowledge that there's been that level of testing done. So meaning, which I feel pretty confident saying that it's nobody's done that level of testing yet, only because when research do this testing, when these researchers do testing for the FDA for the clearance, they end up doing it, of course, not on a human body, but they do it with a phantom and they do it in, patient simulated scenarios. So the impedance, of what we're talking about hasn't yet, to my knowledge, gotten into that level into the mix. And I'll just put a little asterisk here. My guess would be it's not going to matter, but I mean, I could be wrong. If somebody ever does the research, there might be a difference of risk, but I think it's probably unlikely that as long as there's a connection from the device to the skin, I think you always will have that risk. And so, even if your impedance is higher, so then you could theoretically say maybe your connection isn't quite as good. So maybe there would be quote unquote a little less risk. But I'm completely guessing at this point. But the answer is no, not to my knowledge. I don't think any testing has been done to that level. Be a great thing to investigate. And then would be, of course, one more thing for us as our team to be monitoring, before that patient went into the MR. But yeah, great question. Probably terrible answer, but great question.
Oh, I'll take the next question, Maria. So she gives us the scenario, Leah, that in 15 years of EEG, I've had a couple of MRI techs and a CT tech argue with me about the leads. One MRI tech was focused on the conditional term to the point they wanted to see the package and the IFU insert. The MRI was either T2, T Tesla, or 3 Tesla. we use New Prep and Weaver 1020. Is there a quick access study or something that shows the FDA approval if this occurs in the future? So first off, Maria, kudos to you for keeping that, having that IFU, that little folded up piece of paper, because I know many techs, and myself included over the years, we've taken our leads out and tossed that away. So I give you kudos for having that and being able to produce that. Also, yes, there is a quick access. Typically, it is on the internet of the company. Leah, do you want to add anything to that?
No, yeah, I think you're exactly right. That's the place that you go get that conditional information, is from your supplier. So from the manufacturer, your supplier of that device. They'll be able to, if you don't have it readily available, you should be able to get it very quickly and readily available. And there are also sites out there that also are references, but not sure I would use it exclusively. There's a site called mrsafety.com, done by a guy named Frank Shellac. He's very well known in the MR environment. He's created this website that I encourage anybody to go on. It's a great educational area, but he also has like a bunch of stuff from everybody's IFUs kind of in one spot. But his site can be a little tougher, in my opinion, to navigate if you're just looking for like one specific device and IFU to find like that conditional information. So yeah, Sarah, you're exactly right. Just go right to that supplier, right to that manufacturer. If you can't find it, they should be able to like to give it to you immediately.
Yeah, email it to you, something. The next one, definitely we'll need your help with, and that's what I love about this field, is that we're always learning. So Jill is asking us, Leah, you talked about needing the leads to be evenly distributed. What about stereo EEG leads that are all on one side in a way that it obviously is not evenly distributed?
Yep, so that's a different product, obviously. So what I'm talking about is EEG electrodes. So, and just to clarify, that IFU I read is directly from that manufacturer's testing. So that manufacturer went to the FDA with that setup and, sort of like positioned themselves to say, we'd like to be cleared, and we're being cleared with all electrodes being evenly spaced. I am in no way trying to say your electrodes should be evenly spaced at all. I'm just showing you an example of documentation of you use that particular manufacturer's MR product. They only tested with evenly spaced electrodes. So so again, they got cleared with evenly spaced electrodes. So you're exactly right about any other product, but that is a very separate product. So it would have its own, obviously its own path of clearance. But just to make sure I didn't confuse anybody with that IFU comparison, that was showing an IFU that particular manufacturer chose to only get cleared with evenly spaced 10/20 placement. So if you're a clinician and using that product and you have leads come off, or in Sarah's examples, leads that have to come off, leads that have to go on, you are now not in line with the IFU parameters of that device. So then you would have to decide if that device was the right device for you to use on that patient to go in the MRI. So I hope that answered that question. I apologize.
Thank you.
It's confusing.
Yeah, thank you, Leah. And if we have time, I just want to grab one more here, because I know you're very passionate about skin care, and we do have a question about that. Rachel's asking, we have been seeing skin breakdown occur a lot in our NICU patients, specifically on the forehead. Could heat sources in the NICU, such as radiant warmers or phototherapy lamps, be contributing to the skin abrasions as well?
So there was an article that was put out. Oh, I wish I could remember the author. There is a white paper out there about this that says just that their theory, this was probably maybe 6 or 7 years ago. If I can find it, I will try to send it out so it can be sent to everybody. There was an article that was done in an NICU, wasn't with EEG electrodes, but I think it was with EKG electrodes or something, talking about skin health with that population and the heat. And you know, it definitely indicated from their research that it does contribute. And part of it, if you think about it, is because also, you know, that population of our patients, they don't even have developed layers of epidermis. You know, we're abrading the epidermis layer away when we're prepping. They don't even have that developed epidermis usually. So now I'm still having to sometimes prep in some way. And so now you think about that heat. So I can't, again, probably not a good answer. I can't really answer it. My experience when I was at Children's Hospital Wisconsin is we definitely paid more attention to skin health with those patients. I don't know if we tied it to the heat, but it definitely was skin risk health, you know, more of a risk. But it's a great question. And I do think there's documentation out there that supports kind of what I think you might be leaning into, that heat can also be being magnified a little bit by that lead wire, and then ultimately having a higher risk on those patients of skin breakdown. I think you're
Yes.
onto something. Yeah.
I agree. That's a great question. And you did amazing answering that, Leah and Sharon. You know, when you think about some of those things you just shared with that is definitely, we have those NICU babies. Sometimes they're only an hour old, you know, they still got some gunk on them and that. And so just being very mindful, as you pointed out, with the skin dermis not healing that well and just or not being that thick yet and stuff and build up. So maybe use some alcohol swabs, that kind of thing to try to help if you're working on trying to get those impedances down. We've all been there. And then we had one more last one that came in. How do you feel about multiple skin checks? Sometimes I think it causes it. I personally, our policy at the hospital I was just at, we check every other day. Unless it's a real, we did a skin poster in that, and we found that poor nutrition, poor perfusion, all those contribute to skin breakdown. So then there are some that we may need to check more frequently. Do you feel, Leah, that could sometimes cause it if you're?
Yeah, I mean, the reality is you got to put that lead back on. And so, you know, and it's hard to put it back on without doing a little prep sometimes to get a good quality EEG. So, so yeah, I do think depending on the strategy being used for those checks, and to Sarah, exactly to your point, if every patient really needs to be checked or not. But I think it's a great question. And I think it's a great question to sort of be asking, because I do think that if you take a lead off to check for skin health and you're like, oh, skin looks great, but then you want to put it, you know, back on that same general area, 9 times out of 10, you got to prep again. I mean, we all want to believe we can put the lead back on and just you know, seal it back up kind of, and then go on to a great recording. But we all know as EEG techs that usually doesn't work. You usually end up with higher impedance than you've got. So yeah, I do think that you got to be careful a little bit with the strategy being used for skin checks. I think Sarah's advice was perfect.
I think also, just to throw a caveat in there, Lori, is the fact that head wraps, Leah, you and I have talked about that. Like for older kids, our policy was in the EMU, if we've got in-house people monitoring, let them take the head wrap off, and they go a day without the head wrap and stuff, because head wraps, if you're using them, how tight you're using them, what kind you're using, can all play a factor into that too. So, and also, yes, Brian sharing that, found using second skin on the frontal leads helps with skin breakdown. There's various little things out there, Mepilex, the cushions, different things. I also feel wiping off that new prep and making sure you don't have a gob of new prep, and then putting your, or not just new prep, but any abrasive that we use to exfoliate, and then putting the conductive on top of it and then sealing it, whether it be with HipaFix or tape, or I had someone with Tagaderm one time that it was sealed that way, and it's going to breed then with the moisture and the heat. So thank you all for staying on so long after. I appreciate it. We actually, Leah, we still got over 100 on. So
thank you, everyone. It was
yeah,
awesome. I could talk about this all day. I know you're thinking, oh God, please don't let her talk all day. I could talk all day on this.
So Thank you, everyone. Have a great rest of your afternoon, and we appreciate you joining us. It was recorded, so our great IT in the back, Whitney and Max, and Katie, call out to them from our IT and marketing. They'll be able to send you out those links to do your questionnaires, make sure you get your CEUs, and also that you can find this, that it was recorded. You just won't be able to get the CEU if you watch it after the fact. But yeah, thank you, everyone. Thank you so much, Leah. I appreciate your assistance with this.
Oh my gosh, anytime.
All right.
Thanks, Max.
All right, bye.
Thank you
See you,
both.
everyone.
Thanks, everyone.